All right, thanks for coming. My name is Alan Noon. I am one of the Dev Relations Tech Artists with Epic Games, and today we're going to talk about authoring and optimizing 2D and 3D content using a couple of different projects. The first one is Unreal Match 3, and the second one is Soul Dungeon. So Unreal Match 3 would be more of our traditional 2D style, I'll say low-end type of project, and Soul Dungeon is more of the high-end, where we're using real-time 3D characters and all sorts of fancy material effects, so on and so forth. All right, much like my friend Zach, I'm not really a PowerPoint guy, but I went through the effort of making these slides, so you're going to look at them. Okay, so Match 3 is a new sample that we just put together, and we had a few different goals with this particular project, which you can see here. The first thing was an exercise in small team development. Very small group put this project together in a short amount of time. As I said, it's a 2D style game. We are going to showcase UMG, which stands for Unreal Motion Graphics. That's the new UI system in Unreal 4. And we've also implemented in-app purchase and a method for serving ads, the typical sorts of things you'd want to do in a modern mobile game. And also, we wanted to show the split of C++ and Blueprint, the two different languages that you typically create your project with. And we also wanted to replace Tappy Chicken, which I'll talk about. Okay, so gameplay, standard Match 3 type of thing, touch a tile, touch another tile, Match 3, and they explode. Every time you cause a chain reaction or a combo, we build up a power meter along the top, which supplies energy to the bombs that are also littering the field. The more power in the meter, the larger the explosion, the greater chance of a greater score and combo to occur. When you max out the meter, the bombs turn red, and every single bomb on the screen will explode. And it's really a time attack sort of a game. You're trying to get as many combos, as many points as possible before the timer runs out. Every time you hit 25K points, you get 10 extra seconds. So we can actually take a look at that right now. We'll just play for a second here to give you an idea. So I'm going to go ahead and do the mobile preview. Okay. Ooh, wow, resolution is harsh. Okay, all right. Well, rather than futz with res, you'll just have to take my word for it here. But so I'm matching 3 tiles. Here I'm matching 4. As I'm causing combos, you can see that meter powering up there. So if I explode this now, it's going to cause a chain reaction with any other bombs that the explosions hit. And once I get that to max, there we go. So now I just touch one, and they all explode. There we go. So we got a pretty crazy combo there. Awesome. All right. You know what? I am going to take a second here and go ahead and fix up that resolution. So let's take a look at our project settings. Yeah, so we can specify, actually it's editor settings, I believe. If we go down to play, so here we go. We have some common window sizes for the play and editor mode. So let's just, let's turn that down a little bit. Maybe we can go to an iPhone 4. Yeah, portrait, let's try that. Oh, that's actually larger, isn't it? Yeah. Let's try this. Pardon me, bear with me for a moment. Okay, let's try that. Oh, really small. What res are we running at? That's crazy. Oh, this is not good. Ah, 720, okay. All right, fair enough. So you get the idea. Let's go back to our slides. Okay, like I said, small team, 3 to 5 devs, and for some of them, it was the first project that they had ever actually worked on in terms of game development. This took course over the place of 5 to 6 months with people rolling on and off the project, a few hours here, a couple days there, so on and so forth, as their regular day-to-day tasks allowed. So the team really came from different places within the company, the majority from the documentation team. The artist came on board from our marketplace content team, what have you. I like to say that the project was very organic in its development, in that the programmers came on board first and really just started establishing the core functionality of matching and swapping tiles with no real game design other than that in mind. So similarly, the art direction was done in the same way. It wasn't until later that we actually started to direct the art and settle on a look and feel. Yeah, the idea there being prototype now, optimize later. Okay, so I mentioned previously that one of the goals of this project was to show the split between C++ and Blueprint, which is a question that we get asked a lot, both in mobile and console and PC development. What is the right split there? And really the answer is it depends on your team and it depends on your project. Now, Tappy Chicken, as I mentioned, was a project that we wanted to replace. And if you're not familiar with that, let's go ahead and jump over there. This is a great project. It's served us very well over the past couple of years. It was developed by one person, and which is wonderful. Like I said, great example. But the entire game was authored within one blueprint. So menus and the gameplay and scrolling of the screen, every single thing related to this game happens in one blueprint. Great for a one-person team, perhaps, but as you start adding team members, it gets a little more difficult to manage who's working on what. So we wanted to show how you could work in a small team environment by splitting up, dividing and conquering some of the different aspects of the project. So as I said, the programmers came on board first, and they set up the base classes. You can see down here, we have our C++ classes. And there's only a handful, so there's a player controller. The grid is where everything really happens. This is where you define the tile library, the different tiles that you're using. That's set up in C++, but then we went ahead and we went and subclassed that as a blueprint, which is right here. So that allows guys like me, artists, designers, to go in and add the creative end of things, right? Programmers are dealing with the important stuff. They're just exposing the hooks for the creative side to go in and add things like particle effects, camera shake, sound effects, so on and so forth. So let's go back. Yeah, actually, let's go take a look at some of those different things there. If we open up the grid BP again, and we look at our class definitions, you can see here we have, as I mentioned, the tile library. So we could add as many tiles as we want. Currently we have, let's see, this is where we'd set up our gems and our bombs. Actually, we select this in the game itself. That's this guy here. Now if we go to the details panel, we can look at our tile library. So this is the material that this gem is using. This is the probability of it appearing on the field. This is the particle effect color. We're piping in a custom color into the material so that when we're using the same shatter effect, but we're coloring it per gem. So you can see here, this is the green one. And then down here we have the bomb tile. And we have some different abilities. So we can see that this bomb explodes. We can prevent swapping, which, for example, we have these large block tiles that are immovable. So that one's going to be set to prevent swapping. But again, all of this was implemented in the C++ class and exposed to us creative guys to tweak. Okay, we can also set the layout of the playfield as well, so the actual size of the gems. So as I said, initially the art direction wasn't part of the initial effort on the project, so we didn't know what the screen layout was going to be, what size anything was. So again, these parameters were exposed, so we can go and fine-tune this and tweak it as we like. Again, dividing and conquering the creative and more of the engineering side. All right. Okay, so programmers went ahead and leveraged a bunch of existing art assets from some of the sample projects that we had in-house. So the background is just a screenshot from our stylized render sample. The character here is actually a real-time 3D character that comes from one of our original VR demos called Couch Nights. We're using some default UMG. You can see we just have straight up text there, not super pretty. And then the actual tiles themselves come from a marketplace pack, the Kenny LL Platformer pack, which is a great pack. So yeah, let's go ahead and jump over to our launcher here. So marketplace is where you'd find that Kenny LL pack, along with a bunch of great other content. And then from the Learn tab is where we pulled things from, let's see, stylized renderers all the way down here, so on and so forth. So again, I always like to point this out to people. You can go ahead and download these projects, tear them apart, learn from them, actually use the content if you like. We provide the license for all that stuff. Okay. Okay, so let's start talking about optimizations. Once the art staff came on board, again, didn't really know the layout, didn't know what kind of aspect we were going to be using, so we wanted to develop things rapidly and develop things with flexibility in mind, which led to some amount of waste that we could, again, ultimately optimize out. So if we take a look at these materials, for example, let's close him. There we go. Let's shift this around. Take a look at the old materials. Now, I've gone ahead and changed up this material so that it's really obvious to see what's going on. It wasn't actually authored on a big purple background like that. But we knew that we wanted to go for a toon style look or a cell shaded type look with an outline around everything, but we didn't know exactly how thick that should be. So the artist went ahead and created this pretty clever little shader here. Basically, we've got our original texture sample, which looks like this. Normally this would be on a black background. And then we've got a mask, which is basically the same shape with a feathered edge, kind of a blur there. And then we're doing a little bit of math here. We have a stroke parameter, and then we multiply that a couple of times, and then we have what's called a cheap contrast node with another parameter here, which when we go ahead and adjust this value, you can see we have sort of a thin stroke there. I'm just going to crank this up for the sake of this demo. Quick recompile. And now we have a thicker outline. So very flexible, great for initial layout, but again, we're doing some math. It's not too crazy, but again, mobile, we want to optimize as much as possible. So once we figured out how we like things, what we did is we went back and we actually, once we had our layout, we went and authored the stroke into the art itself, which allowed us to chop all of this stuff off and just have a single, simplified material, which we'll look at in a second. Yeah, here we go. Yeah, so carrying around, we ended up with 110 unique materials because for every single piece of art in the game, we had a separate master material. So we were carrying around all of those extra computations and that extra shader compile time. So that was a good place where we could optimize. So the first step, again, was authoring the stroke into the actual material, into the texture. Okay, UMG. So all of these materials were also being used in UMG. So we were calculating the stroke, the outline at runtime, and we were also specifying within the UMG widget that we were going to be using a material. So if we go down to our UI classes, and we'll take a look at our scoreboard. Here we go. So for each one of these images here, you can see this slot with a little red line. That's now a texture. But you can actually specify a material there. If I scroll through the list, all these, the ones with the green strip along the bottom, those are actually materials. So once we authored our stroke, it enabled us to get rid of the real-time material, which was a big savings. Also, it just happens to be that this particular project was originally authored in 4.9, and there was a bug where when using a material within UMG, the gamma was double applied. So like matching colors from different platforms, from PC to mobile, wasn't really working out. Like some things were like super bright, but that has been fixed in 4.10. So if you've encountered that, that should make your lives a little bit easier. Okay, also in validation box. So within UMG, you can see here we have the list of components that make up our UMG. So these images that I'm clicking through, the actual wooden posts or signs in the back, we've got that wrapped in a vertical box so we can align those, but then we've also wrapped it with an invalidation box. Now, if we didn't have that on there, these things would be rendering away every single frame, but with an invalidation box, we can say, render it once, put it up, don't render it again. So definitely a performance enhancement there. Okay, so this is where a big savings was made. As I mentioned, there was like 110 some master materials that we were carrying around. We went ahead and looked at all of those materials once we had authored in the stroke, and we said, well, these could all be the same material. So we're going to go back through and we're going to condense those 110 master materials down to just a handful. So in grand total, it was actually 130 materials, went down to 7 master materials, and then from there we created material instances. So let's close some of this down here. All right, materials. So I'm going to go ahead and filter the content browser by material. So there's our 7 master materials. We've got a couple of simple ones that I'm using on the particles. If we double click and open those, very simple stuff. We're just taking the particle color out of Cascade, and we have an optional texture parameter. We multiply those together and they go into the emissive. So the others are very simpler with just like, I think this one has like an extra parameter in there. Yeah, so we can specify a color from within the actual material to blend that with the particle color. And pretty much everything else is just using this master unlit material. So that's a color, optional texture, just reading texture coordinates. Very, very much simplified. We don't have that extra math calculating the outline every frame. All right, so then again, yeah, let's take a look and filter by material instance. So you can see that we've boiled down all of those into these highly optimized versions of the shaders. So if you're not familiar with material instances, let's take a look at, actually this is great. Let's go back to our gem. This is our most complex material of sort of the standard art. Let's scroll this over, try to make this a little bit bigger. So we've got some, it looks like a fairly simple material when it's running at runtime, right? We've got our gem, that's it. But there's actually some clever stuff going on. This whole area here masks the rendered object from the top of the screen. So unfortunately, due to the resolution, you didn't get to really see it, but at the top we have our scoreboard, we have our character, the gems drop in from there, but thanks to this fun little function over here, you don't actually see the gems until they actually hit a certain location on the screen. Now we could have gone old school and made like some cards that are overlapping at different depths and what have you, but we felt that the expense here was worth it. It was much more fine-tunable, and then as we got into creating custom skins for the game, we didn't have to worry about duplicating those layers and making sure the textures lined up and so on and so forth. It never really works right, does it? Okay, and then we have some additional functions up here for handling of the bombs. So you see we have our statement here. If the bomb is flashing, then we're going to switch this texture there. So not too crazy, but the case, as I said, some of the developers on the team were new to Unreal, and this was perhaps could be a little bit beyond them. So one of the advantages of material instances is that when we create one from that master material, now we boil it down into this very simplified UI. So we can expose the texture that can be swapped out, and then we've got some an emissive multiplier that we don't really use in this particular case. But again, so workflow improvement, simplified UI, but also an optimization. You're not paying for that shader compilation cost when you're using a material instance. Only the master material is compiled. All right, let's jump back to slides. Okay, I think that covered that. Okay, material settings. Again, the style, bright and colorful, tune shaded, outline on everything. So we didn't really need any of the fancy rendering effects that come along with UE4. So we weren't doing any fancy reflections. We don't need, roughness values, so on and so forth. So if we go back, we can take a look at our master material again for our tile. Over here at our head node, if we select that and scroll over, so this particular one, we're just doing straight up surface. It is translucent. Now we could set that to masked. Given the art style that we're using, given that the resolution of the gems that we're displaying, if we set that to mask, we also get a performance enhancement there. We're not actually rendering the alpha around the edges. And we're set to unlit. And then the other thing that you could be aware of to create an optimization is for mobile, in the details panel, we have this fully rough setting. By enabling that, that cuts out the roughness channel. And so it completely eliminates that whole rendering path of doing reflections and all that other good stuff. Okay, particles. So let's take a quick look at some of the original particles. Again, make a little real estate here. Okay, for example, turn off our filter. This was the original bomb or matching particle effect that played. Every time you match a gem, you would get these 3 stars that would spawn out and then kind of drop off the screen. Now, even though this looks particularly simple, it wasn't super performant because these stars were very large. If we take a look at the material that they're using, they weren't taking advantage of some of those settings that we just set in the other material. So they were translucent. They are unlit, which is a bonus, but they were not set to fully rough. And so as these things spawned and overlapped each other and overlapped all the transparent mask stuff in the background, they were kind of killing performance. They also had a very long lifetime. And so the situation could occur where you matched and then you created a combo and another combo and another combo. So by the time you got to the 2nd, 3rd, and 4th combo of spawning these stars, they were still overdrawing against the original stars. So we went ahead and switched that up a little bit. And we made some new effects. So we take a look at the gem shatter there. Let's see if I can make this a little bit larger. So right out the gate, whereas the original placeholder effect just had the 1 emitter, we're actually using 3. We're using 3 different materials in each one so that we can get the different look. And you can see we're spawning like 100+ particles every time this thing explodes. So quite a large difference in the number of particles that we're spawning, and yet this particle effect was more performant. And part of the reason was because of the optimizations that we made to our materials, and also a couple of other things. The size of the particles that we're spawning here, you can see we have all these little white dots. By the time those hit the screen, they're really, really tiny. They're almost 1 or 2 pixels. And you actually get some sub-pixel aliasing, which in this case, we're taking advantage of that and making it gives the explosion, the match, an actual sparkly effect. So we're sort of using that limitation to add some visual interest to this particular effect. You can see we have these really extremely large flares that happen initially. Those take up almost the whole screen every time they go off. And those are like full screen quads. But because they're so short-lived, you're not really paying the cost for a very long time. They go away. And we've got our gem shatters that are also very simplified materials, and they just sort of spin off and die fairly quickly. So, so here's my pro tip of the day, shader complexity mode. If you're not aware of this, again, this is probably going to be a bit awkward. Let's go ahead and play this. I wish that was bigger. Okay, so as we're playing, if I click F5, let's see, we're in mobile preview. Let's go to new window. All right, let's try that. There we go. If we click F5, you can see the different colors here. So green is good. And let's try to get something big going. Here we go. So I've got some bombs going off now. Green is good, red is bad, white, you're fired. But what I decided was that because of the design of the game, when you're actually creating those huge explosions, when all the bombs are going off, yeah, there's a lot of stuff going on. Yes, you're getting a lot of overdraw, but we're actually taking control away from the player. The timer stops, nothing is actually happening, and we give them a second to kind of watch the impact. And then once it all goes away, we turn control back over to the player yet again. So normally you do not want those white effects happening, that white shader complexity. But again, it was a choice that we decided to make given the situation in the project. And again, very short-lived. You don't want that hanging around forever. So if you're developing a game and you go into shader complexity mode and you're seeing that white, you're going to want to have to go back and optimize that. Okay. Yeah, then finally the character mentioned previously. So this is the one sort of real-time 3D piece in the project, originally part of Couch Nights, and had a fairly complex shader network. So let's go ahead and find her. Not too crazy. This portion of the graph here is largely handling her facial expressions. But again, we're using metallic and roughness. And if we look here, let's go ahead and let's find her model in the browser. 1 second to compile. There we go. So you can see all these shiny highlights and reflections. Not really the look that we're going for. Again, chosen art style where we could get away from this sort of thing. So we went ahead and authored more of a toon style, but actually in doing so, when you typically say toon style, people think of cell shading. So there's actually a lot of math going on here to create that sort of look. We're creating a fake light vector to set the direction and color of the light. And then as we come over here, we're actually creating the stair-stepping shading effect that we originally had. You can kind of see that playing across her model there. But ultimately, as the game started coming together, we decided this is not exactly the look that we wanted. So we went ahead and reauthored again and chopped that all out. And went to this here. Okay. So a good number of nodes, but was able to chop out metallic, was able to chop out the roughness settings because we went to fully rough. And the extra cost here, not that incredible, and got us the look that we wanted. Okay. All right, so conclusion with match 3. Example of a low-end 2D style game. The project files will be going up on the Learn tab shortly and all of the accompanying documentation, so you'll be able to download the project, tear into it, see how we did it exactly. And we are also looking at putting this project up on Google Play and the App Store. Our legal team has to work out a couple of things here and there, but hopefully that'll go up so you'll actually be able to download the project on your phone and play it. Oh, we're good to go. Okay, we're good to go. So very soon that should be up. And then because I didn't really know where else to stick it, I'd mentioned the APK size. So 58 megabytes, with approximately half of that being the executable and the other half being the content. Okay. Now, let's go over to Soul Dungeon. So this project was created as another learning resource from our South Korean office. And what they wanted to show was that at the time, there was an extremely popular genre of game. It was like a third-person hack and slash fantasy type of a game. They wanted to show that that type of game could be done in Unreal at a high level of fidelity. As I said, hack and slash, basically what happens is the characters spawn in from the edges of the screen, and you have to survive for 60 seconds, taking down as many as you can. There's all sorts of brilliant effects in here. We've got normal maps, specularity, transparency, fire effects, all that good stuff. Anybody here a former AAA developer, like PS3, Xbox 360 era? Yeah, okay, so that sort of benchmark is really sort of the level of graphics that we're talking about in this particular project, running at rate on the device. So for developers, roughly 4 weeks. Again, people rolling on and off as their normal schedules allowed. There's a little bit of C++, but primarily Blueprint. So let's take a quick look at that. Again, just to illustrate the split of C++ and code. So an item definition, weapon definition. Looks like they've got a custom player controller they're doing there, and something called the Soul Dungeon Blueprint Library. But then everything else is all done in Blueprint. And for what it's worth, this was originally built in 4.8. Okay, so where match 3 was an example of authoring, prototyping quickly, and then optimizing down almost as far as we could go. This project is more of an example of taking high-end content and having it run almost as is with very few optimizations. So if you go through this project, you'll see that there are 67 master materials and just about an equivalent number of material instances. The content was largely brought over from Infinity Blade Dungeons, which was originally authored back in the UE3 timeframe-ish. So again, normal maps, large textures, so on and so forth. Actually, we can take a quick look at some of that stuff. So let's find our character, turn off our filter. All right, so we can take a look at a texture here. All right, maybe not that texture. There we go, there's a normal map. You see 2048 by 2048, pretty huge, right? Okay. And characters, so yeah, again, characters a little bit lower in terms of poly count than sort of a last-gen AAA console PC type of asset. However, again, using the sort of the full boat of material effects, large textures, 30 animations per this particular character, 23 bones, all soft-skinned, and the enemy character, there's a very similarly spec'd enemy character that spawns on screen. And the environment. So the levels are split out into 3 separate components. Let's go ahead and take a look at that. So we've got our persistent level where we've got our basic lighting volumes, nav volumes, basic lighting, atmosphere. Here's where we're holding our spawning logic and our spawners for our enemies. And then this is the actual content itself. So we can go back and look at those specs. So 19 point lights, 3 spotlights. This is the static lighting. We have 1 directional stationary light, so it doesn't actually move anywhere, but we can change parameters on it. 11 different particle effects for things like splashing water. You can see some of that there. And you can see some scrolling materials, some transparency, animated textures. And yeah, actually, the enemies that I spoke of. So in addition to the player character, up to 15 fully skinned and materialed up characters on screen at once, again, all running at rate. And the 3 different weapons, all spawning all sorts of different particle effects. Oh yeah, we could also mention, we've got some dynamism happening here with these animated shaders doing the blowing of the leaves. Okay, so again, an example of high-end content, minimal optimizations running on the target device. Project files, documentation are going to be released soon. And again, APK size, the executable, roughly 23, 24 megs, and then the actual content itself, particularly large, 422.5 megs. So, thank you very much. I will take questions. Yes? What was the target spec for that? So for this particular device? Hold on, let's get the mic over here. Oh. Min spec for device? For that project, for Soul Dungeon? Yeah, actually.
Yeah, what was the min spec for Soul Dungeon?
You know, actually, I don't have the answer to that. But once I get back to my seating location there, I'll contact the developer and I'll see. So just track me down afterwards during lunch and I'll try to get you that info. Yeah, how about right over here? Joe, we got one?
So just like how we have a C++ and a blueprint format for game code, is there something, a similar text format for materials as well?
For materials, no. So all of the authoring of materials is done within the editor here. Technically, there is a custom material node that you can drop HLSL into, but no, it's authored just as its own U asset. We got Joe, one back there.
So you performed a number of optimizations. I'm just wondering, what tools did you use to help guide you in terms of deciding what to optimize?
Yeah, so first I'll refer to some of the features that Zach mentioned earlier, but we'll go into that a little bit more in some of the talks later. But honestly, I brought up the PS3 and 360 era for a reason, and that is a lot of the tricks and techniques that you used back then are valid now on this range of devices. So some of this might seem like game dev 101 to you, like small particles and blending modes and what have you and materials. But I think it's worth mentioning because of all the new developers to mobile. So yeah, but we do have a whole suite of analytics tools within the engine, within the editor, where you can look at performance. For example, I showed shader complexity. That's just one tool, right? There's a whole suite of those as well. Yeah, right here.
Can you speak to where your content comes, like Infinity Blade content? What's your process for bringing that in-game content in and making that available to Epic developers like ourselves, indie houses? And also, when you render that content per platform, do you go through a pre-selection process and say, we want to demonstrate these platforms, or are you just trying to give us content for everything that's out there? So I'm just trying to get an idea of how you guys approach it and what content we can see in the future.
Sure. So the first part of that question is basically where do you get the content, what's available, how do you get it, how do you bring it in? So from the launcher is the best place.
I mean, like from the market, like not inside your product, but in the marketplace, how do you determine that at Epic? How do you bring it in-house?
Oh, so the marketplace is open to all external developers to submit their content. There's a review process, and there's a set of criteria that our council will look at. So quality of content, the amount of content, the relevancy of the content, that sort of thing. And once it's all been vetted, then we can submit it. It can be submitted to the marketplace for sale. Yeah. Was there another part to that question, or does that basically cover it?
Mostly what I wanted to know. I'll follow up with you guys later.
Yeah. The other part was had to do with like platforms and so on and so forth. Yeah, we're trying to cover sort of the breadth of game development, right? So there's high-end content, there's mobile content, all of that stuff. We want to make sure that the authors out there are able to serve game developers of all stripes, really. Yeah.
Is SVG a consideration at all? I mean, it seems like you're doing a lot of optimization for, especially sizes. You're watching your sizes for mobile, but with the plethora of like device sizes, I mean, is there any look into like SVG as a potential source?
So I'm not particularly familiar with that. Maybe Metis or Paul.
I missed the question.
Oh, it was about SVG using that. Maybe you could repeat the question again.
Well, I'm just curious because with SVG, being able to scale to multiple devices, I mean, being able to have one source file and get the quality at a smaller size, because it looks like you guys are considering,
I'm not familiar with the acronym SPG.
what's that?
What's SVG?
Oh.
Sorry, I'm not familiar with the acronym you're using.
Scalable.
Oh, scalable vector graphics.
Yes, yeah.
Right, gotcha. Depending on what you're trying to do, like Flash style scalable vector graphics can be a very useful tool. Because we're not really assembling textures on device, like Allegorithmic has Substance, there are a lot of good solutions out there to assemble content on a device at a smaller size. That's not really kind of because there are some solutions out there that do this, we haven't really focused on doing it ourselves, right? If you want that, Allegorithmics and Substance are great tools to get SVG, scalable vector graphics into textures, recompose them on device, decrease your download size, all that. Internally at Epic, a lot we build technology, and one of our advantages and one of our driving forces is we build the technology we use, right? So we're using this in games every day to drive our needs, and we have not, our artists like to really author things like hand paint, they're in Photoshop, they're on Cintiq, they like that, right? That's what excites them about their job. So we haven't really dug into can we do vector graphics and can we composite things? Can we, do things programmatically to decrease download size? It's been a big focus of ours is how do we make this look awesome and do that without limitations? So, Photoshop, and also the material editor itself is quite powerful. So that's kind of where our artists spend their time and the tools they use. Make sense?
Like, I was just curious if there was anything, like, you could use a material that patterns, but still scale like objects. Yeah,
Yeah, actually, perhaps this will address your question. We do have a feature here. Let's go back to, well, I guess we could do it anywhere. And I believe this is in project settings. Let's see, let's look for scale. User interface. So this curve here, along the top, we have resolutions, and down the side, we have scale factor. So depending on what your, let's say, primary target is, you'll have your certain resolution there. By adding points along this scale, so if you have a different device that has a different aspect ratio, a different size, you'll add a point and then scale that content appropriately. So it's not vector graphics, but you're scaling the actual textures, and this is all hooked into UMG, so things will sort and arrange themselves appropriately. So, Joe, one behind you.
Hi, I was wondering if there was a way of changing the default material previewer from being that sphere to just a plane, because I find it a lot of times I'm trying to just look at it as a plane.
Yeah, I'll use a plane or a cube myself, and I'm always switching it out. You know what? Honestly, I'm not familiar myself, but it seems there is a way to get it to stick, because if we look at one of these other materials on the couch night, this one always defaults to her. So yeah, there's probably some setting up here, perhaps across the bottom. Yeah, you can switch them, but I don't think this particular one saves, but I haven't gotten it to stick yet. Zach probably knows. We'll follow up afterwards, find out for you. Yep.
Do you have any tips and tricks for getting file size down on mobile apps? Like your Match 3 was really small. We've never gotten our stuff that small.
Yeah, again, so texture sizes, obviously, again, this is sort of like game dev 101 old school stuff, right? So all the sort of legacy tricks and tips apply. Those particular textures for that stuff, really, really small. Let's try to find one. That's the first thing that comes to mind. This one's actually 256 by 256, but yeah, anyway. This particular project is fairly simple. It's just the one screen, right? It's going to be difficult depending on your project. For example, Soul Dungeon, we have those characters, 3,000 polys. At the size they are, do they need to be that high res? Maybe not. You might be able to make a choice there. Your skinning, you could go potentially with rigid skinning there. Another optimization.
Yeah, I was just going to kind of reinforce what Alan's been saying. When you look at what your mobile title, what takes up space, your sounds, so mono audio, not stereo, right? Your textures, and there, Alan was telling you, size matters, and then your models and your animations complexity, right? But there's no silver bullet or there's no magic here. Everything has a fixed size, and as over time they all add up, the key is to be aware of what kind of game you're building and try and reuse as much animation as possible, reuse as much, texture space as possible, use the same texture on multiple things, sample, like old school game tricks, right? If you need a random number, sample a random texture, don't, put a noise texture in, things like that, right? And Alan, you've got to go deeper into that, but the trick here is there are no tricks, right? Everything has a cost, know what your individual costs are, know what they add up to, and then be careful with how you're managing them.
Okay, maybe time for one more over here.
Hey, and Alan, we've got one from the stream.
Oh, okay, all right,
Yeah,
we'll do
go
that.
ahead and take.
Yeah.
What is the status of Google Cardboard support?
Oh, good question. Google Cardboard. Is that a Paul question or a cement? It's coming. Okay, it's coming. All right. Okay, from the stream.
All right. So when you have shader complexity, when you have mobile HDR turned on, even the basic shaders appear to be a bit expensive. They're in the reddish gray range. Is that normal? Is there a way to adjust the green red values in the engine at all?
So first part, Yes, mobile HDR is expensive. Second part, tweaking the actual complexity. I'd have to look to see if there's an INI setting there so you can kind of push that up or down depending on your project.
Got it. Cool. Thanks.
Yep. Okay, unless there are any others, thank you very much.